Okay, today in class we learned how to use arithmetic sequences. The first thing you're going to do is determine if a sequence is an arithmetic sequence. Then you're going to find the next three terms, and then we're going to write the explicit equation for an arithmetic sequence.
Okay, I just sent it to
Okay, a sequence is a set of numbers in a specific order. So if we have 1, 2, 3, 4, we can see that they're in a specific order. If we have a number set like this, 7, 10, 5, 0, 2, these are not in a specific order, so we would not say they're a sequence, and we wouldn't use them for what we're doing in this section. Terms in a sequence will look like this. A sub 1 means that it will be the first term. That didn't show up very well. First term. A sub 2 would be the second term. A sub 3 would be the third term. A sub 4 would be the fourth term. And A sub n would be what we call the nth term. It's the term that we haven't defined yet. In an arithmetic sequence, this is a sequence in which the difference between successive terms is a constant, and the graph of this is linear, and this is really important. So if we were to graph an arithmetic sequence, you should get something linear. Also, some keywords in this is difference. That means we're going to subtract successive terms. Those are terms that are in a row. So if I have the terms 1, 2, 3, 4, I could say 3 and 4 are successive. I could say 2 and 3 are successive. Or I could say 1 and 2 are successive. So the common difference, this is the difference. We use the D to represent difference. The difference between successive terms in a sequence. So I just used 1, 2, 3, 4, and 4. Then we can say that if we took these two terms, the difference between them, we would take 3 minus 2 would give us 1, and we would say that the common difference between these values is 1. Another way to look at it is, what are you going to do to get to the next term? And we can see that we would add 1 to those terms to get the next term. Okay, so in example 1, we're going to determine whether each sequence is an arithmetic sequence, and if so, you'll find the common difference. So there are a couple ways to do this. I'm going to look at these two values to find the common difference. We take 0, we take the last term and subtract the previous term, minus a negative 2. Because there's two negatives, it becomes a positive. So we see that the common difference is 2. Another way to look at this is to say, what are we doing to get to the next term? And you can see that we are adding 2, so that common difference is 2. Because we are adding a term, or if we were subtracting a term and that was consistent each time, then we can say, yes, it is an arithmetic sequence. Okay, on B, because you have fractions, I would look to see what number will I use to get a common denominator. And you can see that 2 goes into 16, 8 goes into 16, 4 goes into 16. So we're going to use 16. So 1/2 would become 8/16. You have to multiply this 2 by 8 to get 16, so you multiply the top number 1 by 8. Our second one, we multiply the 8 by 2 to get 16, so 5 times 2 is 10. Our next one, we're multiplying 4 by 4 to get 16, and 3 by 4 is 12. So far you can see that each time we are adding 2/16 until we get to this last term in our sequence, and it says that we are adding 1/16. So because you're not adding the same value each time, you would say no, this is not an arithmetic sequence. On example 2, we're going to find the next three terms. So before you can do that, you have to find the common difference. You can notice what's going on. You can see here that we're adding 11 each time. So to find the next term, you take this 10 and add the 11 to get 21. Add 11 again to the 21, and we get 32, and then add 11 to the 32 to get 43. On B, if you can see what is going on, you can see that we are going to subtract 6 each time to get to the next term. So we'll take this negative 3 and subtract 6, and that'll get us to negative 9. Negative 9 minus 6 is negative 15, and then negative 15 minus 6 is negative 21. Now, the equation for an arithmetic sequence is this, and what this means right here is the nth term. A sub 1 is the first term. N is that value that they give you there. So if they said you had the 12th term, then n would be 12. And D is your common difference. Okay, so there's actually two pieces that we're going to find in this example. So example 3 says, write an equation for the nth term of the arithmetic sequence, then graph the sequence. So we have to identify some things. The first thing I'm going to look at is what is our first term, and you should be able to pick out that from your sequence. It's negative 12, and then you're going to find the common difference. The common difference, what's happening each time to each value, we're adding 4. And then we're going to go ahead and use that formula, a sub n equals a sub 1, negative 12, plus n minus 1 times d, which is 4. And then to simplify this, we distribute the 4 through. So a sub n equals negative 12 plus 4n minus 4. Then you'll combine like terms and get 4n minus 16. Now, this is very similar to y equals mx plus b. If you were to look at this equation, you would say our intercept is negative 16, our slope is 4. And you could use that information to graph, or I would come up here to my set that I was given, and I would say that this was my first term, my second term, my third term, and my fourth term, and I would use those to graph. And I would use this as my x distance and my y distance. So it says my x is over 1 and then down 12. I can see that I'm not going to get down 12, so I'm going to change my scale to negative 2, and this will stay a scale by ones. So over 1, down 12, I'm still off my graph. I'm going to go over 2, down 8, 2, 4, 6, 8, over 3, down 4, 2, 4, and over 4, down 0. Ooh, let's try that again. Then we get this line. Now, if you notice, our slope here is up 2 over 1, but remember we went by 4, so it's actually up 4 over 1, which is the same value that we get there. And if you were to continue along this graph, eventually you would cross the y-axis, and it would be down at negative 16. So here's your next one. Again, we begin by finding a sub 1, and that is your first term, so it's negative 1. Then we find our common difference, so what is occurring each time? It looks like we're adding 2. So then we go to our a sub n formula. A sub n equals a sub 1, negative 1, plus n minus 1 times d, 2. And then we'll simplify this by distributing the 2 to both and get 2n minus 2. And then one more step, we'll combine our like terms, negative 2, negative 1, and we have 2n minus 3. Now you could use this to graph, and it would say that we start down at negative 3, and our slope is up 2 over 1, up 2 over 1, and then draw your line. Or you could go back and use your chart. We haven't created it. And you'd say that this was our first term, second term, third term, and fourth term, which tells you that we would go over 1, down 1, which puts us right on the line, over 1, sorry, I did that wrong. No, over 1, down 1, over 2, up 1 puts us on there, over 3, up 3 puts us on our line, and if we went over 4, up 5, we would still be on our line. So either way, you can either use this as a table of values to graph, or you can use your linear equation there to graph. Example 4 says use the following arithmetic sequence to find the following. So here's our sequence. It wants us to find some things. So before I go on, I would identify a sub 1, that's our first term, and it's 1 in this case, and d, the common difference. So what are we doing each time to the term? It looks like we're adding 9. And then I'm going to use this information. It says find the 12th term. So a sub 12 is what we're looking for, is equal to a sub 1, and we're just using that formula of an arithmetic sequence, plus n minus 1. Well, n is 12, times d, 9, and then we just simplify this. 1 plus 11 times 9, 1 plus 99 is 100. So our 12th term would be 100. Now you could actually take this sequence, the 1, 10, 19, 28, and write it out so that you have 12 terms, but this is going to be a more effective and faster way to get to that term. B says which term of the sequence is 388. Well, this represents your a sub n, so we're going to use that same formula and replace the a sub n with 388 is equal to a sub 1, 1, plus n, we don't know, minus 1, times d is 9. And then we're just going to do some algebra to solve this. Distribute the 9 through, combine like terms, add 8, I'm going to go over here, 396 equals 9n. From here you divide by 9, so you'll get n equals 44. So the 44th term of this sequence would be 388. Okay, so that should help you with your assignment 5-4 arithmetic sequence worksheet.